Assalamu alaikum, Ali. Can you hear me? Assalamu alaikum, Ali. Can you hear me?
Yes, Assalamu alaikum, I can hear you.
Okay. Ali, what are the updates? Have you done some revision? I had sent you some formulas and told you to learn them because formulas are very important for such a difficult test.
Yes, I also read the
So
chapter
did
of
you learn them?
wave, the general wave properties chapter I was reading from the book.
Very good. You have that CI book?
Yes, I have a book. It has like a brown cover. It says physics for A levels, but it has like many chapters different. So I'm not really sure if it's the updated syllabus or the old one.
Mm, okay. And the formulas are important, and some important things are like the drawings are important. Now, let's try some questions. I'm starting from this, and the first I'm putting is if you have your past paper book, you can check this one, and if you haven't done, then we can try that. It's November 2012 to 3. So, do you have this question in your book?
The book is like kept somewhere else. Should I get it?
uh, is better because otherwise you can solve it on this with me. And right now we are not writing answers, we are solving. So solve, you can do a solution on anything. State one property of electromagnetic waves that is not common to other transverse waves. The answer would be that they can travel through
Vacuum.
vacuum. Very good. They can travel through vacuum. This is a unique property. All electromagnetic waves can travel through vacuum. The 7 regions of EM spectrum are represented by blocks labeled A to G, and they are showing you here. A typical wavelength for the visible region is 500 nanometer. Name the principal radiations and give a typical wavelength. Remember, I had shared you a table and I reminded you to learn them because it's very helpful to remember all the important frequencies or wavelength.
Yes, I remember. It was like 10 power 10. Then it went from
Hmm.
that to 8, 6,
Yes, so
5,
it's very
4.
important to learn them. So he says a typical wavelength for the visible region D. So they have marked D, and you know that if it is D, wavelength is decreasing. Wavelength is decreasing, so it's reverse mate. So it means that the left side is higher wavelength and G side is shorter wavelength. So should I mark it here that it is ultraviolet?
Yes, it will be ultraviolet.
Then,
X-rays and then radio waves.
no, no, no. After X-rays, it would be gamma
Gamma.
rays. What about if I come down? I have infrared, then micro, and then radio. This spectrum must be learned by heart.
So the visible region must be the visible light.
Yes, visible region means Vibgire. Now, can you recall for me some wavelengths? That is important to learn them by heart. So B, as we marked, what is B? B is microwaves. Do you remember the wavelength? You can look on the WhatsApp if you want, you can see the table.
I remember the frequency, not the wavelength.
It's okay then. If you remember the frequency in the paper, you have to convert it into wavelength by the formula C is equal to F lambda. So if you remember the frequency, you can put it here and you divide it by C divided by F. This is how you do that. So you can try that, or you can open the table on your mobile and you look at it if you want to go directly. But for tomorrow, you should remember it. Okay, any number for micro. Microwaves are bigger wavelength waves. They are the second largest wavelength. You can give it, suppose 10 power minus 2. They can go up to 10 power minus 2, 10 power minus 3. What name we have suggested for E, that is UV. Now, can you suggest anything for, do you remember the visible light has a wavelength of, very strongly remember it, 400 to 700 nanometer. This is the range for visible light. Now, UV can be taken, you can select any number in, if you remember it.
It was 10
So,
minus 6.
minus 6 is shorter. Minus 6 is actually bigger. So you have to make it shorter. You can select minus 7 is even fine. The F number is X-rays.
So this will be minus 8, like one more.
No, at least you have to give a jump of 2, but you can check it later. If there is a difference, you can put it as minus 7, and you can cross 9. You can say minus 10. So calculate the frequency corresponding to a wavelength of 500 nanometer. So the formula is F is equal to C upon lambda, and it is 3 into 10 to the power 8 upon 500 is nanometer. Now this comes. Can you help me in making the calculation?
So what is the C? It is the wavelength,
Of light.
the light
Yes,
speed of
C
light.
is a constant and C stands for speed of light.
The answer is 6 into 10 power 14.
Okay. And the significant issue might be there. So let's check. All they have given one sig fig, so it's look fine. All the waves in the spectrum shown in figure 5.1 can be polarized. Explain the meaning of the term polarized. Let's quickly revise. When a normal wave starts, it spreads out in all possible directions. If you restrict the oscillations in one plane, it is called polarization. So what is polarization? It is a process in which the oscillations in a wave are restricted to one plane. Can you repeat for me? What is polarization?
It is the process through which the waves are like restricted to
Oscillation
one plane. Oscillations are restricted to one plane.
to one plane. So this will be a good diagram to remember. And in the paper, you can use it to explain that originally a wave contain oscillations in all directions. But once you polarize it, the oscillations are confined to one plane. Now we have this question. This is November 13, 21, and 5. A long rope is held under tension between 2 points A and B. Point A is made to vibrate vertically and a wave is sent down the rope towards B as shown. The time for one oscillation of point A on the rope is 0.02 second. He says one oscillation. So I can guess that he is giving me time period. The point A moves a distance of 80 millimeter during one oscillation. The wave on a rope has a wavelength. This is lambda. Explain the term displacement for the wave on the rope. So you remember that when we were doing this chapter, we made some definitions and did you revise some work from the notes?
Yes, the displacement was like the distance from the unmoved
Mean
position.
position. Yes,
From the
very
mean.
good. Up right above the mean position. So the concept is there. Displacement is the separation of an oscillating particle from the mean position. Now we move forward. Calculate for the wave on the rope the amplitude. So he says for one oscillation, it travels 80 millimeter. It means it goes down, it comes back. This is one oscillation. This is costing 80 millimeter. And I hope you remember, I'm shading it dark. Is this amplitude?
The amplitude was the mean, displacement from the mean position.
From the mean position. Very good. So I know the going total downward, doing coming up, the whole up, you can see this much is 80. So what should be the amplitude?
So it will be half of 80.
No, he's trapping you. It can't be half. Look, it goes down all the way. It comes up all the way. And you're talking about only this much. It goes down like this, comes up like this. Then it becomes 80.
Okay. So it will be 80, the amplitude.
No,
Double.
just compare now. This total is 80. And I am giving this, asking this two-way, going down and up, coming up. Going down and coming is total 80. So this is amplitude. It will be 80 upon 4. Can you get it?
How how will it be 4?
Look, you go down and you come up. This total journey is 80. And now I'm asking how much this will be.
Okay, okay, I got it. So it will be like half we took from the downward portion and half from the up. So it will become.
It is the fourth part of 80. It is actually complete journey and he is asking for a quarter of it. Now, what is the speed? How we can find speed? The formula says V is equal to F lambda. This is the formula. V is equal to F lambda. Now, how we can find it? We have the wavelength 1.5 and we have the time period. We can use directly this formula if you remember. V is equal to lambda upon T.
Okay, so this was the one before the derivation. Then we will make this 1 over t and change it into
Very good.
frequency.
That's good. Wavelength was 1.5 and time period was 0.2 and you divide it, you get speed.
It will be 7.5.
Good. Now on figure 5.1, draw the wave pattern on the rope at a time 0.05 second later than that shown. This is a bit tricky part. You have to read it carefully. You have to compare this number with this number. Can you compare 0.05? Is it one complete cycle is 0.2? So 0.05, will it be the quarter of one cycle?
Yes, it will be 1/4 of the complete cycle.
Yes.
So 1/4 portion more will be drawn.
You have to move 1/4.
Okay.
So where am I? Okay, where the wave is. Okay, here is the wave. So should I make this much or
Yes,
it
equal to
is?
that of the amplitude.
But you have to be careful what I'm asking. Is it half cycle or quarter cycle?
It is a quarter cycle.
Look, what is one cycle in waves? If you look carefully, uh, this and this is one cycle. Am I right? Did you get the point? This is one cycle of a wave. So what I have drawn, is it or quarter cycle?
So this will be a half cycle.
Yes. So it means we have to correct it and you have to draw this much only. State and explain whether the waves on the rope are progressive or stationary. What is the difference between progressive and stationary?
In stationary, it will like the energy won't leave the medium or the
Yes,
source.
and stationary waves are always well identifiable because they form a
Loop.
loop, and you can find, is there any loop? Remember
No.
the discussion we were making yesterday? The loops appear like this one. So this is not a stationary wave, it is a progressive wave because it is carrying energy and leaving. Okay. What about longitudinal or transverse?
It is a transverse wave.
Good. Because the particles are moving up and down and wave is going like this.
So it
This
will be
is,
perpendicular to the direction of the
yes,
propagation
very
of
good.
the.
It's perpendicular to the motion of the wave. This is our next question. Define for a wavelength. So what is the definition of wavelength? Can you recall?
It is the distance between two successive or like troughs or crests.
Okay. And it's a separation between two consecutive trough or two consecutive.
Tre-
And
Uh,
what was the, remember what was the official definition? It is the separation between two consecutive points which are exactly in phase. What about frequency?
Number of oscillations per second per unit time.
This is a good point to remember, that never say per second. Always say, CI gets very irritated by this word. Always say per unit time. Never say per second, because remember, when you are defining a physical quantity, you should never mention a unit. Time is the quantity, but second is a unit. You should never mention a unit in a definition. Use your definitions to deduce the relation between lambda, f, and v. This is a well-known derivation. You start with velocity is equal to displacement upon time. For one cycle, and you should do this with me so you can get revision of it. There is no need to write down the definitions, but calculations and other things you should write. And I think onward, you can keep the book with you and you can write in the book if you find the question. This will save your time next time when you are completing a topic. One cycle. So for one cycle, d will be equal to, the distance will be equal to lambda, and t will be equal to capital T. So once you do that, you will get v is equal to lambda upon t. Then you say to examiner that look, t is equal to 1 upon f. So you put it like this, lambda upon 1 upon f. It will become f lambda. This is a derivation. It's better that you try it yourself also, make a writing memory.
Wasn't it like the F is equal to 1 over capital T?
It's the same thing. It's the same
Oh,
thing because they are reciprocal to each other.
I've written it.
Plane waves on the surface of water are represented by figure 5.1 at one particular instant. The wave has frequency 2.5. Determine for the wave the amplitude. Remember, amplitude is the height of a wave, and he's trying to trap you because he has not given us the central x-axis. I'm drawing it for you, and now you can see that what would be the amplitude. Amplitude is the height. Look, this is the amplitude. Now, can you find the amplitude for me?
So this time it will be 4, like because it is half.
Yes, it is 4 millimeter. Yes, 4 millimeter. What about the speed?
So we will use F is equal V is equal F lambda, and
Yes. We have the frequency, but what about lambda? You should count the distance given. You can see the distance given is 18. Till here, it's one cycle, two cycle, three cycle,
so
and is it 3.5 or
3.5 it will
quarter
be.
to 4? Is it 3.5 or it is 3.75?
I think it is 3.75.
Yes, very good. It is 3.75. So 3.75 cycle gives you 18 centimeter. So one cycle is X. Can you get this thing for me? It is X become lambda.
It is 4.8 centimeter. So do we have to convert this into meters?
You
For
can
the
always check it from the question here. The question nowadays, they guide it that you should convert or not.
the answer is coming as 0.12.
0.12.
0.12.
0.12. Good. The phase difference, which is symboled as delta phi between points A and B. Okay, this is A and this is B. You can always remember that 1 lambda, I hope you remember this most important concept of the chapter. 1 lambda corresponds to a phase difference of, do you remember? 1 lambda corresponds to a phase difference of
2 pi
how
radian.
much? 2 pi radian. This is the most important concept of this chapter. Always remember that. I've drawn the line again for discussion. Now, I have to look for the separation between A and B. Now, I should know how much it is of lambda. Is it if I take my journey from, sorry, if I take my journey from A to B, if I take my journey from A to B this much, I shade it for you. Is it 1 lambda, half lambda, or quarter lambda?
This much is, I think, lambda by 4.
Remember, what is 1 lambda? If you travel from here, look this one and this one. This is 1 lambda.
Okay.
So
So
what
that
is
will be
this?
half lambda.
Sorry?
Half lambda.
Yes, perfect. It is lambda by 2. If 1 lambda corresponds to 2 pi radian, then lambda by 2 will be,
This will be pi radians.
yes, good. You have reached it. So you will write it here. It is pi radian.
So sometimes in the diagrams in the questions I was doing, I faced difficulty in finding the angle difference between them, the phase difference. So because this is
This
like
is
a
the hmm?
triangle, so then we take it as 180 degrees or pi radians.
No, I don't think so. You need to find are you talking about the superposition chapter?
Like in both of them, in this we can also take it as node 2 and we can take it as lambda by 2. So that is also pi radian.
That's lambda to lambda, because there is no need to apply trigonometry anywhere. Just like you have just seen this calculation, the rule is very simple. Convert the separation in terms of lambda and then use this concept. I repeat, the method is very simple. Convert the separation in terms of lambda and then apply the ratio lambda equals 2 pi radian. Whatever question he gives you, you can tackle it with this rule. But trigonometry is not needed in this case. The wave in B was produced in a ripple tank. Describe briefly with the aid of a sketch diagram how the wave may be observed. Do you remember ripple tank? It's a tray of water. There is a dipper in it, and we move the dipper to produce waves. Below the dipper, there is a paper sheet, and above the tray, there is a lamp. There is a lamp. And how we used to run this, if you remember this topic, we used to run it by the instrument called as signal generator. This is a rough diagram. And you should draw it with me. I will try to share a diagram with you so you can remember it. It is no need to make a very accurate drawing.
Okay, I remember this. It's like the ripple tank we saw in which like water waves were created. And then through the
Yes,
lamp, because of the reflection, we could see like the waves move beneath it.
yes. It is basically a type of projection. The real diagram is quite challenging, but the concept comes when you see a better diagram. I have shared with you, and you can see if it comes to you, then you should remember that a rough diagram I have made for you. Have you copied it? Did you copy it?
I've copied it.
Good. Now, just I want to restart because there is a hanging occurring. I'm starting the class, and you can join just very after it. I'm terminating this session and starting a new session.